I am Anil Kumar, and in this video we will understand how to write equation for a function from the given information about the asymptote. The question is, write an equation of rational function for the given condition. Conditions are: equation of horizontal asymptote is y equals to 0, function approaches positive infinity from above and negative infinity from below the horizontal asymptote. That's the end behavior. And we have vertical asymptote along x equals to 1. You can pause the video, answer the question, and then look into my suggestion. So let's first sketch, then be easier for us to write down the equation also. So what we given here is horizontal asymptote y equals to 2. So let us say this is y equals to 2, right? So this is y equals to 2, horizontal asymptote. Then says function approaches positive infinity from above and negative infinity from below. So that means the end behavior is kind of like this. So function is approaching, right? It's never touching, but it's like approaching like this. So it is approaching positive infinity from above and negative from below. So that is the end behavior. And then says vertical asymptote along y x equals to 1. So we have vertical asymptote which is x equals to 1. So let us say this is x equals to 1. So these are the conditions given to us, and we have to write a function which will satisfy all these conditions. Right? Now there could be more than one solution to this. Let's understand how to write this kind of function. Since vertical asymptote is at 1, we can write denominator as x minus 1. So that will ensure that denominator is 0 for x equals to 1, and we do have a vertical asymptote which will be at x equals to 1, right? So this is 1 for us, that is 2. Here we have x, and here we have f of x. Now the difficult part is, 1, that the horizontal asymptote should be at y equals to 2. This is y equals to 2. Second, the end behavior. The function will be approaching horizontal asymptote from below and when you approach negative infinity, and from above when you approach positive infinity. That is to say that if x is approaching infinity, in that case, that is to say that if the limit as x approaches negative infinity for the function, it has to be 2, but since it is less than 2, right? So 2 minus, that is what it means. And it also means that limit for the function as x approaches positive infinity should be 2 plus. This is what it means. That is the end behavior which we need to ensure. Now, best way to get this kind of an answer is make the denominator positive, right? So if I make whole square, it becomes always positive, right? Now what I have to do here is that 1, I need 2 as my horizontal asymptote, and therefore now here if you expand this, you'll get x square, right? So x square, so the degree should be square, that is first part, and since horizontal asymptote is 2, the coefficient of this should be 2 times, right? That is one more important thing, correct? So that is it. So that will ensure that we have horizontal asymptote y equals to 2. Now to ensure the end behavior, what should we do? Let us check with a value, let us say minus 100. If I write minus 100 here, in that case, denominator will be minus 101, which is more than 100 in the numerator. So we expect a value which is less than 2, correct? So it works, right? And if I write a value which is plus 100, then plus 100 minus 1 is going to be 99, right? So that is going to be 99. And if it is 99, then 99 square, when you divide 100 square by 99, you'll get a number which is more than 1, and so it will be more than 2, correct? So that should really work. So what we found is that this is just the right function. So we can write this as 2x square over x minus 1 whole square, correct? To test, what you should do is you should test with x equals to plus 100 and x equals to minus 100, just to check, do you get a value If you test with plus 100, more than 2, and if you test with minus 100, less than 2, right? If yes, then this is the right equation. I hope that helps. Thank you and all the best.